Hello friends, welcome to UGPG Mathematics. In this video, we are going to solve some questions from 2019 and from 2015. So let us start. The first question is, let P2 be denote the set of all polynomials over R of degree at most 2 with respect to the inner product. So inner product of P with Q, where this P and Q are polynomials over R. This is just integration from -1 to 1, P of t, Q of t dt. Then the set of vectors 1 comma t square minus 3 is. First option is not a linearly independent set. Second is orthogonal basis of P2. Third is basis of P2 but not orthogonal. And last option is orthogonal but not a basis of P2. So let us solve this. So for this, we just have to remember that basis means it must exhaust all the polynomials, right? So that means if we take any polynomial P of t, then we can write this as a linear combination of these elements, right? Now we know that this 1 comma t square, this is a standard basis for the space P2, okay, or P2 of t. So this is just, so this third vector t square minus 1 by 3, this is just a translated vector, right? So this also forms a basis of this P2 of t. So this is a basis of P2 of t. Now the only question remains that this is orthogonal or not. And we know that this is a basis, so it must be linearly independent. So this is not true. So let us check whether this is orthogonal or not. So for this, what is the condition for orthogonality? We have, suppose we have two polynomials, then these are orthogonal if their inner product is 0, right? Now polynomials means we have this 1 t square minus 1 by 3 here, right? So if we take p equal to 1 and say q equal to t, then check this inner product pq is 0 or not, right? So what is the inner product? This is just equal to -1 to 1 integration, and then 1 into t is just t dt, right? Now there is an important result. Now just don't calculate all these integrals and all. Now this is odd function, okay? So integral of this odd function will be even, right? As we can see, this is t square by 2, right? But now look at these limits. Limits are just of the form -1 to 1. That means the number here and here it's negative, right? So this t square will be 0 because 1 square, when we put the limit, it is just 1 square minus of 1 square divided by 2, but this is same as 1, so 1 minus 1 is 0, right? So whenever we have odd function here, odd degree function here, this integral is 0, right? So when we take 1t, we will get this inner product to be 0, right? Now take another pair. So suppose we take t and then the third vector t square minus 1 by 3. So what is the inner product? This is just equal to -1 to 1 t into t square minus 1 by 3 dt, right? Now this is even function, this is odd function, so product is just odd function. And we have just seen that if we have odd function here, then this integral is just 0, right? So we have this inner product is equal to 0, right? Now let us check for another pair. So 1 with this, so 1 with t square minus 1 by 3. So what is this? This is just -1 to 1, 1 into t square minus 1 by 3 is just this. This is t cube by 3 minus 1 by 3 times t, right? And this is from -1 to 1. Now when we put t equal to 1, this is just 1 by 3 minus 1 by 3. Similarly, when we put t equal to minus 1, this is just minus 1 by 3, then minus of this is minus 1, so this is plus 1 by 3. So this is 0, this is 0, and hence this inner product of 1 with t square minus 1 by 3 is also equal to 0. So PQ is equal to 0, inner product is 0 for all PQ in this basis. So call this as B for all PQ belongs to the set B, and hence this is orthogonal set, and we have seen that this is a basis, right? So this is orthogonal basis for the space P2 of T. So this second option is the correct option. Now let us solve the next question. The remainder when the number 5 raised to 2019 is divided by 11 is. So we just have to find out 5 raised to 2019 is congruent to what mod 11, right? This number is called the remainder when we divide this number by 11. So how to find out this? So there is an important theorem which is Euler's theorem, which says that if we have a GCD of A and N is 1, that means they are co-prime, then A raised to 5 of N is congruent to 1 mod N, right? Now take A is equal to 5, take N is equal to 11, GCD is clearly 1. So by using this theorem, we have 5 raised to 5 of 11 is congruent to 1 mod 11. But what is 5 of 11? Now just note that 5 of P, where P is a prime, this is just equal to P minus 1. So this is just 5 raised to 10 is congruent to 1 mod 11, right? Now we just have to reach this 2019 from this 10, right? So how to do this? We can write this 2019 as 201 times 10 plus 9, right? So take the power 201, right? This number. So this is just 1 raised to 201. So this gives us 5 raised to 2010 is congruent to 1. Now 1 raised to anything is just 1. So this is mod 11 as it is, right? But now we want 2019, right? We have 2010. So just multiply by 5 raised to 9. So we will get 1 into 5 raised to 9. So this is just 5 raised to 9. Now by rules of indices, we have this index is just 5 raised to 2019 is congruent to 5 raised to 9 mod 11, right? Now what is the main task? We have to find out this number, and this number is modulo 11. So just find out this number. So take modulo of these numbers, modulo 11 of this number. So here 5 raised to 9, we can write this as 5, 5, 5, right? So 9 times, yes. Now when we multiply these two numbers, this is 25, then this is 25, then this is 25, this is 25, and one more 5, right? 9. So this is 5. Now this 25, so when we take modulo 11 of this 25, we get the number 3, right? Because 25 is just equal to 11 into 2 plus 3, right? So when we take modulo 11, this is just equal to 3. So reduce this, so it is 3 for this pair. For this pair it is 3. Again for this it is 3. For this it is 3. And for 5 this is just 5, right? So we have 3 into 3 into 3 into 3 into 5, right? Now this multiplication is again 9, this is again 9, and this is 5 as it is. Now this, just note that this 9 is congruent to minus 2 mod 11, right? Because this 11 divides 9 plus 2, right? So this holds. So this 9 is same as minus 2, same as minus 2. Now minus 2 into minus 2 is 4, and this 5. So 5 into 4 is 20, and now reduce this 20 modulo 11. So 20 is clearly congruent to 9 mod 11, right? So we have this 5 raised to 2019 is congruent to 9 mod 11, right? So what we have did is just we have written this number as 5 raised to 9 mod 11 is congruent to this thing, and we have reduced this number modulo 11 and we get this as 9. So this is the remainder when we divide this number by 11. So this second option is the correct option. Now let us solve the next question. The order of Sylow subgroups of a finite group G of order 56 are. So here we have given the order of group is 56, right? So take the prime factorization of this. This is just clearly 7 into 8. So what is the prime factorization? 7 into 2 cube, right? So these Sylow subgroups are, basically there are Sylow 7 subgroups, because we talk about Sylow P subgroups, right? Sylow 7 subgroups and also Sylow 2 subgroups. So what is the order of Sylow 7 subgroup? This is just 7. What is the order of Sylow 2 subgroup? This is just 2 cube, right? So which is just equal to 8. So the orders of this Sylow 7 and Sylow 2 subgroups are just 7 and 8, and hence this second option is the correct option. Now let us solve the next question. The radius of convergence of the series, this summation n runs from 0 to infinity of 1 by 2 raised to n x raised to 3n is, option number 1 is 1, then infinity, third is 1 by 2, and last is 2 raised to 1 by 3. Let us first compare this series with summation an. So n runs from 0 to infinity. So what is our an in this case? This is just equal to 1 by 2 raised to n times x raised to 3n, right? Now we know that by ratio test this series converges absolutely if this n is limit as n tends to infinity of, by ratio test, if this limit is strictly less than 1, right? So we will use this formula. So take the ratio. So what is the ratio of an plus 1 upon an? This is just equal to 1 by 2 raised to n plus 1 into x raised to, now x raised to 3 times n plus 1 is same as 3n plus 3 whole thing divided by 1 by 2 raised to n times x raised to 3n, right? This is our modulus of an plus 1 divided by an. Now this is just same as, so this 2 raised to n will get cancelled with this, so this is just 1 by 2, and this is 3 raised to n, and this 3 raised to n. By the way, this is just e raised to 3n times x raised to 3, right? So this is just x cube, right? Because this will get cancelled with this. So we have L is equal to limit n tends to infinity of 1 by 2 times mod of x cube. Now we want this must be less than 1, right? So this is just equal to, now note that this quantity is independent of this n. So this limit is just equal to 1 by 2 times mod x cube, right? So this is our L. So we want this must be less than 1. So this is just same as we want mod of x cube is less than 2, right? Because we multiply by 2 on both the sides, we will get this quantity. So this is equivalent to take the power 1 by 3 on both the sides. So this is just mod x is less than 1 by 3. So this number here is called the radius of convergence. So this r is just equal to 2 raised to 1 by 3. So this D option is the correct option. Now let us solve the next question. The sequence, this 2 raised to n plus 1 plus 3 raised to n plus 1 divided by 2 raised to n plus 3 raised to n converges to 1, 2, 3 or 5. So let us first recall that if we have r is a number such that this modulus of r is less than 1, then r raised to n or r raised to n plus 1 converges to 0 as n tends to infinity. So just remember this. So that means what? If we take, suppose for example 1 by 2 is equal to r, then r raised to n, so this is same as this, which tends to 0, right? Or if we replace this by n plus 1, then this also tends to 0. So we just have to take some adjustment of these terms. So take the bigger number and multiply and divide by this number. So from the numerator, multiply and divide by 3 raised to n plus 1, right? So this is just equal to 2 raised to n plus 1 divided by 3 raised to n plus 1, which is just same as this quantity, plus now we are dividing by this 3 raised to n plus 1, so this is just 1, right? Similarly, divide and multiply by 3 raised to n, so this is just 3 raised to n times 2 by 3 raised to n plus 1, right? Now we just have seen that as n tends to infinity, this quantity tends to 0 and this also tends to 0, right? Because 2 by 3 is strictly less than 1. So this raised to n converges to 0 and also this raised to n plus 1 converges to 0. So this quantity converges to, now this 3 raised to n, so this quantity is just same as 3 raised to n times 3, right? So 3 raised to n will get cancelled with this, and this is just 3 is a constant. This tends to 0, this tends to 0. So this is just 0 plus 1, 1 divided by 0 plus 1 is 1. So this limit is just equal to 3. So this C option is the correct option. So let us solve the next question. The limit of the sequence root of n plus 1 times n plus 2 minus n as n tends to infinity is. So for this, whenever we have something in the root, just rationalize this quantity. So when we take root n plus 1 times root n plus 2 minus n, so rationalize this, that means multiply and divide by root n plus 1 times n plus 2 plus n, right? Just change the sign to minus to plus, then divided by the quantity, this quantity n plus 2 plus n, right? So just multiply these two brackets, we get this is n plus 1 n plus 2 minus n square and divided by this is n plus 1 n plus 2 plus n, right? Now just simplify this. So this is just equal to n square plus n plus 2n, so this is 3n plus 2 and this is minus n square, right? So this n square will get cancelled with this n square and we have this is just equal to 3n plus 2 divided by square root of, so this was square root of n plus 1 times n plus 2 plus n, right? So simplify this, we will get n square plus 3n plus 2 square root plus n, right? Now take n common from this, so this is just equal to, now first take n square common from this bracket. So this is just equal to n into 1 plus 3 by n plus 2 by n square, and take n common. So this is n plus, from this it is just 1, right? So this is just same as n 1 plus 3 by n plus 2 by n square, and this is plus 1. We have 3n plus 2 divided by n times square root of 1 plus 3 by n plus 2 by n square plus 1, right? Now take n common from the numerator. So we get n into 3 plus 2 by n. Now cancel this n with this n and take limit as n tends to infinity. So what is the limit? It is just 3 plus, as n tends to infinity, this tends to 0, divided by, now this tends to 0 as n tends to infinity, also this tends to 0. So this is just equal to square root of 1 plus 0, and this plus 1 as it is. So this is just equal to 3 by 2. So this C option is the correct option. I hope you like this video. Thanks a lot for watching. Please like, share and subscribe if you find this useful. Thank you.